Hey guys, my name is Katie Haywood and I'm the SciFar STEM coordinator for Richmond, Anson, and Marlboro counties. Do you miss watching your favorite sports team and cheering them on? Today we will be playing a sport of our own called Score. Before we get into playing our game, we have to first understand why we are doing this. So the objective of this 4-H Daily Spark is to learn more about Isaac Newton's 3 laws of force and motion. The first law of force and motion that Sir Isaac Newton discovered is that a ball at rest will stay at rest unless you kick it. Rule number 2 is that the harder you kick a ball, the faster it will go in that same direction. And then rule number 3 is that when 2 balls collide, they will go backwards in a same speed in an opposite direction, otherwise known as every action has an opposite and equal reaction. Now that we know a little bit about the famous scientist Sir Isaac Newton, let's put his actions into play and start getting our ball game together. So I'm going to show you how to fold your paper football. So first, you'll fold your piece of paper in half lengthwise, or hot dog style, and you'll fold it in half lengthwise again, and you'll have this really long, skinny piece of paper. Then you're going to fold it in half hamburger style to create a crease in the middle of your paper right here. You got your crease right there. Then you'll use the left side of your paper and you'll use that crease in the middle to make a triangular shape here. You'll take your longer side of your paper on this end and you'll wrap it around the front, and then you should flip it around so that you can see an L. So you have your L shape with your triangle in the middle, and then you'll take the top part of your L and you'll fold it behind your triangle so that there's a small flap left on the bottom. You'll fold that small flap up and you'll tuck it into the pocket that is created by the triangle. Then you'll take this last piece right here and you'll fold it in front of the triangle piece so that a crease is made there. And you'll also fold the small flap that's left over so that a crease is made there. You will unfold it and you should see your small crease there and your crease there. You'll fold your small flap in and use your square that's made to tuck into the triangle pocket, and you're left with 2 triangles. You'll fold the triangles in half. You have to make sure that you press really hard for this part. And you'll tuck the lower triangle into the pocket that is made by the upper triangle. And you have a paper football. You're going to do this 3 different times with 3 different pieces of paper. So here I've used construction paper, notebook paper, and computer paper But at home, as long as you have 3 different types of paper, you can be able to determine Newton's laws and see them in action. You also are going to need a measuring device of some sort. Now let's go outside and play some ball. Okay guys, so we have come into the backyard and I have created a launch pad with a tape measure, and I have a notebook here to write my data down. And so I have my 3 footballs, and we're going to start with the notebook paper football. Start with the smooth side towards you and the triangle pointing that way out. And you're going to use your fingers to thump on the smooth side. So you're going to do this 3 times. The first time you will do it a very light flick. The second time you will put a little more force into it. And then the third time you do it as hard as you can. We're going to put our paper football in line with our measuring tape. We're going to flick it lightly. And so our paper football landed on the 24-inch mark. Now we're going to do a second football flick, and we're going to do it a little harder.
47.
So we're at 47 inches. I'll write those 2 down. So the first light flick was 24 inches. The second medium flick was 47 inches. And now the hardest flick is 84 inches. So the harder that you flick the paper football, the further it will go. Now we're going to try a different type of paper. We're going to use our computer paper. And you do the exact same thing that you did with the notebook paper. You try to keep your light flicks the same as your previous light flick and your medium flick the same as your previous medium flick so that you have consistency. So we'll take our computer paper football and we'll line it up with our tape measure and we'll lightly flick it.
36.
So it's at 36 inches. We'll record our data. Now we're going to do a medium flick.
48.
At 48 inches. And now our hardest flick
$75.
75 inches. So now we're going to use our construction paper football. This one is a little harder to flick because it's much thicker. So you still want to try to remain consistent in your light flick, your medium flick, and your hard flick. So we put it at the very beginning of our measuring tape. We're going to do a light flick.
40.
At 40. Okay. Now we're going to do a medium flick.
56.
56. And then our hardest flick.
84.
84. Now we will look at our data and we will look at how this applies to Newton's laws of force and motion. Okay, so while we were outside, we realized that the harder that we were able to flick our paper footballs, the further it went. We also realized that the heavier the paper was, for example, our notebook paper is very light and flimsy, but our construction paper is much heavier. So the heavier that the paper was, the further the paper football went. Thanks for watching the 4-H Daily Spark.